So I am Laura, and I am going to present my research that really sets the stage for our randomized control trial on the performance of drought-tolerant maize on farms and how it compares to what we're seeing with our sample of farmers that are perhaps more representative of farming in this region. So my research addresses the yield return of drought-tolerant maize on farms, and we've been talking about this. Olaf really set it up and told us how they were developed. But what I find is that indeed drought-tolerant maize does have a yield advantage over comparison varieties. And further, that yield advantage is increasing in drought pressure. So the more drought, the better, or the sort of bigger the difference is between the drought-tolerant maize and other varieties that are available on the market. And then what's interesting is that I find that there's a difference in that advantage, in that performance of DT maize, on the basis of farm sort of performance levels. And so the gains to the drought-tolerant maize varieties are lowest for the farms that are underperforming relative to what we might expect. So the data I use to evaluate this is the on-farm trial data from CIMMYT. So these are conducted with collaborating farmers across Eastern and Southern Africa. And I have an unbalanced panel. So what that means is I have some observations across multiple years on the same farm from 2011 to 2015. And so the way these on-farm trials work is with these collaborating farmers, they will plant both DT varieties and comparison varieties sort of side by side in the same conditions, whatever nature throws at them in their farm area. Then what I contribute to this data is I map each of those locations to high-resolution rainfall data and also temperature data to look at what the farms actually experienced. So I can say more specifically whether or not it was a drought year, when that drought occurred, and how that within season sort of variability in rainfall impacted the yield levels. So Olaf gave us the background, but just to recap, CIMMYT developed these varieties, and they targeted resilience to drought pressure during that pollination stage. So there's two very vulnerable stages for maize, and the first is that establishment, sort of that germination stage, and then the pollination stage is when CIMMYT targeted the crops to have additional resilience. And so far, there have been really large estimates of what that yield advantage might be. So in some cases, they found more, the DT varieties had more than twice the yields of the comparison varieties. But in general, a lot of the research so far finds yield advantages of about 20% to 50% relative to comparison varieties. So I untangle that a little bit. So I just mentioned the timing of rainfall is very important for maize yields, and in my research, I look at sort of the very specific periods of rain and how the crops respond. So mostly I'm looking at that mid-season period. Now, the breeding of the crops was done, Olaf described this a little bit, with what's called managed drought stress. So this is just a stylized illustration where they irrigate the crop very well all the way through the establishment, that first vulnerable period, but then dramatically turn off the irrigation during the germination stage. And they will resume the irrigation at the end just so the plants don't die, and in this way they can select for varieties that do well. And so right here I'm presenting some data from on-station trials. So these are the ones where they can control the irrigation, and in this first set of bars we see that in optimal conditions on station, DT maize does do a little bit better. That's about a 10% yield gain. And they have extremely high yield levels. And so I selected this particular on-station trial because it is the region that's most similar to our own study region. So There are on-station trials that have even higher yield gains, but this is a region that's most similar to where I was working in Tanzania. Now, under the managed drought stress, reasonably, the yields drop. And so in the second one, the blue bar is the DT maize, and it has about a 50% yield gain over the comparison varieties. So what that's saying is that under the drought pressure, DT maize continues to do better, and actually quite a bit better than what it's comparing, what we would compare it to. Now, I'm gonna now look at sort of how my rainfall data come into evaluating the DT performance. So the FAO recommends that maize should receive about 500 to 800 millimeters of rain in kind of a rain-fed context. And so what I have here is each of those on-farm trials and their sort of season's worth of rain. And so you can see the majority of them do fall in that FAO recommended window. And so what I'm curious about is those that sort of are on the bottom half of that. Now, I showed before the sort of stylized illustration of the managed drought stress. This is sort of a different illustration of maybe what rainfall might look like on the farm. So there's not this perfect comparison of what happens when you have great rain and then no rain. It's going to be a lot more sort of all over the place. And so what does that do to that DT yield advantage? So now I'm comparing the on-farm trial data, and so that that set I've labeled pooled, that's the pooled sample, so that's all of my on-farm observations across all of the countries, all of the types of years. And we can see that there is this sort of, so starting from the optimal settings for DT maize, there is a drop in the yield levels going from sort of optimal to this random drought stress, sort of whatever's happening on the farm. And there's also a sort of drop in the difference between the DT and the comparison. So that's about a 3% yield gain sort of pooled across all of my sample. But what becomes interesting is sort of how the DT varieties do with increasing drought pressure. So this figure is presenting some of my estimates of how DT performs. So on the x-axis is the rainfall levels, and that rug plot is representing all of the observations of rainfall for the on-farm trials. So that's just to show you a density of what actually happened. And then the solid line is the DT maize yields. So you can see that yields are increasing with rainfall. And the dotted line is the comparison varieties. And what's notable here is sort of the gap between those two lines. So what that's saying is at high drought levels, so on the left-hand side of the figure, DT maize does a lot better than the comparison varieties. And then that advantage shrinks as the conditions get better. So what I've presented so far is the mean effect, the average effect of DT maize on yield levels. Now, the average collaborating farmer in the on-farm trials is actually quite different from the farmers that are in our sample that Steve's about to talk about. And so I also did a quantile analysis approach, which will allow me to take farmers based on their performance levels, or their farm's performance levels. So that kind of captures any of the differences that might be in this sample, looking at soil quality or perhaps agronomic practices, fertilizer application, anything like that. And so in that situation, I'm now presenting sort of two different potential ways to look at the sample. So the on-farm trial pair of bars that's labeled drought, that's just any on-farm trial that did experience a drought. And you can see this, the DT maize sort of continues to do quite well relative to the all of the pooled sample, but then the comparison maize is really what suffers. But then I'd really like to draw your attention to that 25th percentile group. And so that last set of bars is showing that for the farms that are sort of underperforming relative to what we might expect, they are not seeing that same gain to the DT maize. And that could be, that could be due to soil type, that could be due to sort of any number of things, but if, what we're looking for is to increase the performance of the the lowest performing farms, then this isn't quite cutting it. So almost all of that gain to DT that you can see in that drought one is actually going to those top performing farms. So this is that same figure that I just showed you, but I plotted on it the 25th percentile of farms, and you can see again, maybe DT is doing a little bit better, but essentially there's very little difference between the DT and the comparison varieties on that sort of 25th percentile of farms. So the main takeaways here, DT maize advantage does increase in drought pressure, and I do find that most of that increase is due to resilience during the mid-season drought. But there seems to be a variation in that return to DT, where those lowest percentiles of farms, the underperforming farms, are not actually experiencing sort of that DT bump and that additional drought resilience. So perhaps the gains to DT maize for smallholder farmers, like the ones that we target in our sample, are not as large as suggested by previous research. And that sort of yield gap, that difference in the potential and then what farmers are actually seeing, is likely due to sort of this interacted set of agronomic stresses. And it's like soil quality or agricultural practices, or even the potential for early season drought. So, thanks.
Any quick questions for Laura for clarification, or we can?
And we can combine them. Oh,
just
sorry.
a clarifying question. So can you go back to the last bar chart?
Mm-hmm.
Yeah, this one. So just to be clear, the 25th percentile here it's comparable to the pooled bars, right? So it's not comparable to the drought. So this is not drought conditions for the 25th percentile.
Correct.
It's the 20th percentile. So we should be looking at the pooled bars versus the 25th percentile.
Correct. Yeah. Thanks, Travis.
And you were saying, so the gap, but the gap there doesn't look that different between DT and non-DT, right? Is that?
Yeah. So the gap between the full pooled sample and the 25th percentile is not that different. In fact, it's a little bit larger for the 25th percentile, I think, but there is a big gap. You can that you can see in this drought subsection, and that gap is mostly due to the top performing percentile.
We don't see that here.
We don't see that here, yeah.
Because there's not a drought by 25th percentile.
Correct. Yeah. So I did not include that.
So
Yeah.
when you were saying that the DT effect is much smaller for the 25th percentile,
Mm-hmm.
that's not something we see on the screen, but it's something that you see in the data.
Correct. Yeah.
Good. Any other quick questions? Or?
Mm-hmm.
Yeah.
Oh.
I'm trying to look at the differences in yield
Mm-hmm.
across all the bars, and even for the drought group where the difference is quite large.
Yeah.
Did you test to see if it's significant, the difference? And did you compare to the difference in yield versus the cost of the investment cost to see if it's really a gain to invest that much to get that difference?
Yeah, so that's a great question. One thing that the first question was, is the difference in yield significant? Yes, I am finding significant differences in yield. The second question is about sort of the cost efficacy of it. And Steve will maybe talk a little bit about what we were seeing with prices in our project. with these data are the on-farm trial data. So in this situation, this is where seeds are being, Olaf can correct me if I'm wrong, seeds are being given as a package to the collaborating farmers. So I would give Michael, I want you to test these DT varieties and these comparison varieties, and then you're going to report back to me. So in this situation, I have neither seed prices nor maize value. In our sample in Tanzania, I know that the price of the DT maize was almost the exact same as the sort of any variety we might compare it to. So in some cases, the DT maize was actually about 10% cheaper than the leading sort of hybrid competition. Some cases, it was maybe 10% more expensive, but really all within the same range, where the hybrids just kind of cost about the same. So since I am finding a significant yield advantage to DT maize in some situations, in that case, it would make sense to purchase it.